The goal of today's lesson is to solve factored or factorable equations using what's called the zero product property. Okay, to demonstrate this property, we want to take a look at a couple of examples or situations. If I were to list the pairs of numbers that multiply to 20, and I'm specifically talking about integers, okay, I have 1 and 20, 2 and 10, and 4 and 5, and I have their negative counterparts. But if I wanted to list the numbers that multiplied to 0, well, basically it's any number and 0, where a is any real number. So what is this showing us? What's our observations here? Well, our observation is that there is a finite list of pairs for 20, but infinite for 0. Would it matter if I use some number other than 20? No. If I use 6, I would just have fewer pairs. If I use 48, I'd have more pairs. So what does this tell us? What we're focusing on today is what's called the zero product property. And what the zero product property tells us is if A times B is equal to 0, then either A or is with an O, or B is 0, or A and B is 0. Now, what's the relevance of that? Well, we're going to take a look in a second. Let's look at this following table here. If I wanted to solve x plus 3 equals 0, well, clearly we know it's x is negative 3. And if x minus 5 equals 0, we clearly know that x is 5. Well, are both negative 3 and 5 a solution to the equation of multiplying both of these? Well, if I put in negative 3 for x, I'm going to get 0 times negative 8. It works. And if I put in 5 for x, I'm going to get 8 times 0, and that works. So yes, negative 3 and 5 are a solution to these two binomials individually and to the product of them. Even though one of the parentheses in each case didn't come out to a 0, as long as one of them does, that works. Now, contrast that with the two equations that I've changed, not equal to 0, but equal to 20. Well, you'll see I get 17 here, and I get 25 here. But if I were to put 17 in for x, well, does that product equal 20? That should be pretty obvious that it isn't, because it's going to be 20 times some number. And if I put in 25 for x, that should also be pretty obvious that it's not going to equal 20. Okay? Because the zero product property only works when we're talking about multiplying to 0. What you're seeing is each of these two pair of parentheses is 20, and 20 times some other number, unless it were 1, doesn't give you 20. So let's take a look at some examples. Which equations can I solve by using the zero product property directly? Okay? That's important here, because I can solve these other ways, but I want to, the point of this exercise is for you to see how or if the equations are already trued up to be solved directly. The answer to this one is no, since it is equal to 6 instead of 0. Right? This answer is yes, it's already trued up, and I can see that x is negative 1 and negative 2. This one is yes, and I can see that when I set each one equal to 0, x is 2/3 and x is negative 12. This is also yes, and only one solution since they're the same binomial, which is 3. This is also yes, it's set equal to 0, and I have three solutions, negative 4, a positive 6, and a negative 5/2, setting each parenthesis equal to 0. And then finally, this is no, because this is separated by a plus sign, so they're separated by addition and cannot be factored. You're going to see what I mean by that in a moment. Okay? And again, we're only asking what can be done directly. You'll see in the Friday's lesson, the 1.13, where we actually went through and solved those that were set equal to 6 using our quadratic equation rules of setting it equal to 0. So now let's look at the next example and contrast these two. This one can be solved because you'll notice they have a common factor of x minus 5. So I can rewrite this statement here as such, and now I can easily determine that 5 and negative 4 are my solutions. So that's what I was referring to there. Okay? Now, last two examples. How could I solve x squared minus 2x minus 15 using the zero product property? Remember, what we're trying to do is to get two statements or expressions multiplied by each other. Well, you should recognize that x squared minus 2x minus 15 is a trinomial that can be factored using the I am method, which is one of the reasons factoring is so important in this course. How would I do that? X minus 5 and x plus 3. Now, I'll split this and set each one equal to 0 and get my solutions of 5 and negative 3. How would you check this? Well, if I inserted 5 for x to the original equation, you'll see that it works. And same thing for negative 3. Now, would it work here to factor and leave it equal to 20? Hopefully you should be saying to yourself right now, no, this is not set up for the zero product property. But can we set it up? Yes. By doing what? Subtracting 20 from both sides. Now, I have an equation that's set up to use the zero product property. I will factor using I am, and you will see that my solutions are 7, negative 5. And if you went and substituted them back into the original, they will indeed work. So the point to today's lesson was to show how the zero product property is used to solve quadratic equations. And what we're talking about is a situation where we want to have two expressions multiplied by each other set equal to 0.